Welcome to Rival Institute. Now discussing the joint probability function. In joint probability function, we are discussing in the discrete cases. So we have a continuous cases and discrete case. Now we are discussing the discrete case. So we have a x is a random variable and we have one more random variable y. Y is another random variables and x is one random variable, y is another random variable. So taking the one example, we have dice. So two dice, we are throwing two dice. So this is a x die and we have a y die. So this is the y die. Y result is getting from throwing this dice, and x result is getting from throwing this dice. So both dice. So dice, what is a particularity of dice? Dice have this its face. So this is a 1 and 2, 4, 6, 5, 3. We have 6 faces. So this dice is throwing. So here is a one die, here is a one more die. This two dice is throwing at a time, single time. So what will be the probability? So maybe I will get a 1, 2, 3, 4, 5, 6. In top of the dice, maybe I will get the top of the die maybe 6 or maybe 3, maybe 2. So this all have a equal probability. 1 by 6, here is 1 by 6, here is 1 by 6. So 1 by 6, 1 by 6. So all are getting the equal probability. So I am throwing two dice at a time. So single time I am throwing the two dice. So how to represent in single time I am throwing the two dice. So I got the x. Yes, I got the x dice, I got the result of 6 and y dice I got the result of 4. You see how I represented here? Two dice are thrown, so I got the number 6 in this die. This die I got the number 6 and this die I got the number 4. So I represented x equal to 6 comma y is equal to 4. This is equivalent to the x equal to 6 intersection y is equal to 4. Or we can write here like that, x equal to 6 and y is equal to 4. So we can represent a different way, but this is a representation in joint probability distribution. So this is represented here, f of x and y. F of this is a random variable. You can take a capital x and y. F of x and y is representing probability of x is equal to x comma y is equal to y. So this is a representation of the joint probability distribution. Probability of x is equal to x, y is equal to y. So this is a meaning, x is equal to 6 intersection of y is equal to 4. This is the same meaning, we'll get the same result. So what is x is equal to 6, y is equal to 4? What will be the probability? Probability of here x is equal to 6. What is the probability of getting x is equal to 6 in dice? This is a 1 by 6. There is a x is equal to 6. So there is a chance of 1 by 6. What is the probability of getting y is equal to 4? So this is equal to 1 by 6. Same probability, getting the same probability. So total probability will be 1 by 6 into 1 by 6. So this will be a 1 by 36. We getting the chance x is equal to 6 and y is equal to 4. That chance will be 1 by 6 into 1 by 6, 1 by 36. So two dice are throwing, we will get 36 outcomes. We will get the 36 outcomes. How will get the 36 outcomes? So we can draw the outcomes, then we'll understand. So here it is. So we get in the 36 outcomes. 1, here I am writing 1, 2, 3, 4, 5 and one more column 6. So this is representing by the 1 and 2, 3, 4, 5, 6. So I getting a lot of 36 outcomes like that. Now see, I have a chance. If I am throwing these two dice, I have a chance. 1, x is equal to 1 and y is equal to 1. So this is representing y, this one is representing x. So I have a chance. X is equal to 1 and y is equal to 1. I have a chance x is equal to 2, y is equal to 1. I have a chance here x is equal to 3, y is equal to 3, both are same. I have a chance here it is x is equal to 5 and y is equal to 2. Here you see y and y is equal to 5, same probability. Here is 6 and 6. So all are have a chance. I have all chances is there. If you are throwing 2 dice at a time, I have all the chances. There is a 36 chances are there. We can write as a 36 chances. And what will be the probability? All have the equal probability. We can write here it is we got the answer. Here it will be a 1 divided by 36 probability. So this joint probability will be 1 by 36. Here also this joint probability will be 1 divided by 36. Here also there is a 1 by 36. All the column will be 1 by 36. You see 1 by 36. Here is 1 by 36. So all the column will be 1 by, all are have the equal probability. All having the same probability. All they have x is equal to 6. Here is represented x is equal to 6. How to represent this column? Probability of x is equal to 3 and y is equal to 3. X is equal to 3 and y is equal to, so this is probability also is equal to 1 by 36. Same probability for all the cases. Probability of x is equal to 5, y is equal to 4, x is 5, y is equal to 4. So this also has a probability of 1 by 36. All having this probability of 1 by 36. You can fill 1 by 36 like that. So this is the joint probability. It is representing like a probability of x is equal to x, y is equal to y. So this is a representation of the joint probability distribution. Hope you understood how it is getting the term. It is a meaning of a intersection of y is equal to 4 or and both we can use. But commonly we will use the representation of probability x is equal to x, y is equal to x. We can take one more example. If you are throwing the coin, so we have throwing the 2 coin. So we have a 2 coin. To coin, what is the chances? We have a chances of head and tail. So we have a 2 coin. Just write here. This is a head and that side is a tail. So here this is a head and this I am trying tail and that side is head. So this coin is tossing the coin. So this is a coin tossing. So what will be the probability? Probability of x is equal to h, head. What is the probability? It is a 1 by 2 chances. Equal h or t. And probability of y is equal to t. What is the probability? It is also 1 by 2 chances. So how jointly we are tossing 2 coin at a time, same time. How to represent x is equal to h, comma y is equal to t. We got the x is equal to h, head, and y coin. This coin I got the result of tail. So what will be the probability? 1 by 2 into 1 by 2. So this is probability is equal to 1 divided by 4. So what are the possibilities we will get? If I am drawing the, what are the possibilities are there? This is x and this is y. This is head and tail. So here head and tail. So I will get the chances. I have a chances of probability of x is equal to head and y is equal to head. Both have the head. I have chances. If this also getting head, this also getting head, this also 1 by 2 chance, 1 by 2 chance is a 1 by 4. So this my probability is 1 by 4. I have a chance of probability of x is equal to head and y is equal to tail. So this also probability is equal to 1 by 4. I have a chance probability of x is equal to tail and equal to head. So this probability also 1 by 4. This also 1 by 4. So in joint probability I am representing here like that, x is equal to head and y is equal to h. So I hope you understood how to represent the joint probability, how to take the values from the diagram. So I have a chart. If x is equal to head and y is equal to head, what is my probability? It is a 1 by 4. X is equal to tail and y is equal to head. What is my probability? It is also 1 by 4. Y is equal to tail and x is equal to head is a 1 by 4. So this I have to take from this chart also. I have to write this values from the chart. This is a representation, and if you have to write here also it is a 1 by 4. Here also it is a 1 by 4. So that is a probability. So hope you understood about the joint probability function. We can do some problem. We'll understand. So we have some random variable x and y. This probability distribution chart. So this is representing x. X is representing 1 and 2 and 3. So we have 3 chances is there. This is also 1, 2, 3. So these values are 0.1, 0.1 and 0.05 and 0.15, 0.2, 0.1 and 0.05 and 0.2, 0.05. So these are the chances. So this is 0.2. Now you see the graph is like that. So we have 3 random variables in x and y. We have 3 random variables x and here it is a y. There is a chance of y is getting 1 and x is getting 1. What is the probability? It is a 0.1. So how to write this one? How to represent probability of x is equal to 0, x is equal to 1, x is equal to 1 and y is equal to 1. What is the probability? We have to take from the graph. It is a 0.1. X is equal to 1 and y is equal to 1. It is a 0.1. And what is the probability of x is equal to 2, y is equal to 3? What is the probability? X is equal to 2 and y is equal to 3. So this is equal to 0.05. And what is the probability of x is equal to 3 and y is equal to 3? So this is equal to 0.2. So we know that how to write from the chart. We have taken x is equal to 2, comma y is equal to 3. We represent it as a joint probability. So this is 0.1, 0.05, 0.2. Now we have a sigma x, sigma y, f of x comma y. This is a total probability. Total probability of x and y, it will be a 1. This total probability will be 1. If you are add, this is 0.1, 0.1, 0.05 and 0.15. If you are adding this total probability, you will get the total probability will be 1. 0.1 if you are adding here, and if you are adding here, this total probability, this will be a total probability will get the 1. So that is the meaning of total probability. Total probability, if it's then the graph, if you are adding the all the values, probability values, you get the total probability has to get the 1. So now you understood about the how to write the joint probability distribution, and we know how to take from the values from the graph. X is equal to 1, y is equal to 1 is 0.1. Now we will move into the marginal probability distribution. Marginal probability function. What is a marginal probability function? This is a marginal probability. We will write here. Marginal probability. What is a marginal probability function? Marginal probability function. So now you see we have a graph, and in marginal probability function we will represent in x alone or y alone. Its representation is like that. F of x, this is capital S. F of x is equal to is representing function of x alone, sigma y, f of x comma y. X alone, here it is x alone, is here is represented as a x alone, there is no y terms. So how to write the x alone? X alone is representing like that. Probability of x is equal to 1. There is no any other probability we are taking. Probability of x is equal to 1. That is x alone. What is the probability of x is equal to 1? We know that the probability of x is equal to 1, there is a chance of 0.1 and 0.15 and 0.2. So 0.2, 0.3, 0.45, 0.45. There is a chance of 0.45. And what is the chance of probability of x is equal to 2? So this is x alone. We are not considering the y. So what is the probability of x is equal to 2? There is a probability x is equal to 0.1, 0.1, so 0.25. So there is a chance of 0.25. You are adding the 3. And what is the probability of s is equal to 3? What is the probability here? 0.1 and this is a 0.3. So this is a representative marginal probability. Marginal probability function is representing x alone or y alone. So we can represent y alone also, f of y, y. So this is will get sigma x f of x comma y. So how will get the probability of y alone? Y alone will get the probability of, you can consider the y alone. So this is x alone. You are taking the probability of y. Y is equal to 1. What is the probability of y is equal to 1? So this is a probability 0.1 plus 0.1, this is 0.25. So we can write 0.25. Probability of y is equal to 2. So 0.15, this is 0.2, 0.3, 0.3. So here it is a 0.3. And here it is a 0.45. So probability of y is equal to 3. It is a 0.45. So this is a marginal probability function is represented in h terms. H terms is represented here, and we are adding all the possible values of 1 h, all the possible values and right here, and all the possible values of s is 2, and all the possible values of s is equal to 3. If we are y, then y is equal to all the possible values of y's, and we added here, and we got the probability of y is equal to. So this is a marginal probability function. We can take one more example. Instead of these values, I am taking the here it is 0, here it is 0, and 0 0.1, 0 0.1, 0 0.2, here it is 0 0.2, 0 0.2, 0 0.1, and here it is 0 0.1. So this is the graph x and y. What will be marginal probability of x is equal to 1? What will be my marginal probability? So I have two random variables, and joint probability function is given in x and y. Joint probability function is given in x and y. This one I can write here. It is a probability of x is equal to 1, y is equal to 1. That is a probability is equal to 0.1. And what will be the probability of, this one is a probability of x is equal to 2 and y is equal to 1. This is probability of 0.1, and there is no probability here, it is 0. Now how to write the marginal probability? Marginal probability of x is equal to 1. So what is the probability of x is equal to 1? So this is a marginal probability. We have to add all the y terms, 0.1, 0.2. So this is a 0.4. So I got the 0.4. Probability of x is equal to 2. So we need to add here 0.3. So this is 0.3. We are adding here also 0.3. So probability of x is equal to 3. That is also equal to 0.3. So this is the marginal probability. Here if we are adding as y is equal to 1. So we have to add here 0.2. And if you are adding here, this is 0.4. This is 0.4. Is equal to 1 is equal to 0.2. And probability of y is equal to 2. 0.4, and probability of y is equal to 3, y alone 0.4. So this is the example for the marginal probability function. So I hope you understood about how to represent the joint probability function, and next is how to write the marginal probability function. This both cases we studied in the discrete case only. Thank you.